add or subtract rational expressions with monomial or binomial denominators. So you'll either have a variable in the denominator, which is like an x, or you'll have a binomial, which would be like x minus 5 or x plus 1. So we're going to consider this subtraction. It says write the lowest common denominator to the two. So pay attention. If I had this on the denominator of one, x, and I had an x plus 5 on the denominator of the other one. Oh, good. My computer's being awesome. Do you know how many people tell me I just add a plus 5 to this side and now they're the same? Remember, what you do to the bottom, you have to do to the top, right? And remember yesterday or Friday when we had like 4 and 8, you times 4 by 2 and 2 and you get an 8 in the denominator, right? You multiply to get a common denominator, correct? So if you're telling me that I just add a plus 5 to this, I'm actually multiplying that plus 5, correct? When I multiply plus 5 to x, what do I get? 5x. I don't get x plus 5. You can't just add a 5 to this. They actually have nothing in common. This one is x. This one is x plus 5. You'd actually have to multiply them by each other to get a common denominator. There's nothing common to these two. Okay? The biggest error is that you times this by plus 5. You times by plus 5, you get 5x, and now you're 5x and x plus 5. You're no much better than you were before. All right. So let's look at one that's a little more complicated. But often people find this easier than the previous example. So this one has an x minus 5 in the bottom. This one has an x plus 1 in the bottom. So what's common to x minus 5 and x plus 1? Trick question. Nothing. Nothing is common to x minus 5 and x plus 1. So the lowest common denominator is the two of them together. So what's the lowest common denominator? It's x minus 5 and x plus 1. There's nothing in common. So they complete the work shown below. So they have the original. Okay, we're just watching, we're just paying attention to see what they do. Then they're timesing, they're multiplying the left side by x plus 1, x plus 1. They're multiplying the right side by x minus 5, x minus 5, correct? Now with adding and subtracting, you distribute the tops, but the bottom you leave as two fractions. Or two factors, sorry, not fractions. Two factors, and you don't put them together. So basically, I have a common denominator of the both, right? So I can write them all over one denominator, right? So I can go 2x plus 1 times x plus 1 minus this times this. We agree? Then they still leave the bottom separate, x minus 5 times x plus 1, but they FOIL this out. So 2 times x is 2x squared. 2 times x plus 1 plus x is 3x. So they put them together. And then 1 times 1 is plus 1. Then minus sign and a bracket. X squared minus 5x minus 4x is minus 9x. Minus 4 times minus 5 is positive 20. Why do they have this in brackets? This x squared minus 9x plus 20. Why is it in brackets? What did I tell you about subtraction on Friday? Yeah. Right. This ends up changing every sign behind. So you could change this to a positive and change the signs of everything behind it. Basically, you have to distribute in, you're subtracting an x squared, you're subtracting a negative 9x, and you're subtracting a 20. So in the next step, we would have x minus 5x plus 1 on the bottom. We never put those together. And in the top, I'd have 2x squared plus 3x plus 1. That doesn't change. But everything else behind the subtraction sign does, because we're subtracting everything behind it. So we're going to get minus x squared. Minus a minus 9x is plus 9x. And then minus 20. And then our last step is to collect like terms on the top. So 2x squared minus x squared is just x squared. Plus 3x plus 9x is plus 12x. And then plus 1 minus 20 is minus 19, all over x minus 5, x plus 1. And you're done. You should state, however, that x can't equal 5 or negative 1. You still just state the denominator MPVs. with the binomials. Yeah, that's all they did. So both of the denominators were binomials, and neither of them were the same. So they just multiplied the left side by the right-sided binomial, and this one by the left-sided binomial. We'll do more practice. Okay. So here we have 2x, and here we have x minus 4. Is there anything common to 2x and x minus 4? No. So if there's nothing common, then I'm going to multiply the right-hand side by 2x and the left-hand side by x minus 4. But what I do to the bottom, I have to do to the top. So I have equals x minus 9 over 2x, and I have to multiply it by x minus 4 on the top and the bottom. Plus, and this one I'm going to multiply by 2x on the top and the bottom. So this one I multiplied by that denominator, and this one I multiplied by this denominator. Okay? Our next step is to write the entire top over one denominator, because right now I have a common denominator, don't I? So I can just write x minus 4 times x minus 9 plus 2x times 3x. So literally just writing that whole top over x minus 4 times 2x. We agree? So all we did was we wrote the numerator over the denominator, right? Yeah. I'm not sure what you're asking. I'm going to get x times x, which is x squared, minus 4x minus 9x, but I'm not going to do that in one step because that confuses people. So I'm going to go x times negative 9, which is negative 9x. All I'm doing is foiling, right? Negative 4 times x, negative 4x. Negative 4 times negative 9, positive 36. And plus, I have a plus sign, 2x times 3x, which is 6x squared, all over x minus 4 times 2x. And I'm not going to put those together because I never put the denominators together. What's my last step to do once I've distributed? Collect like terms. So I'm going to get x squared plus 6x squared is 7x squared. Minus 9x minus 4x minus 13x. I put these together. And then I just have the 36, so plus 36. All over x minus 4 times 2x. And I'm done. But I have to say x can't equal 0 or 4. You have to be able to do adding and subtracting, or you won't be able to solve, which is tomorrow. Okay? Solving is one more step. Yeah? You could FOIL out the denominator, but it isn't going to make it any better. They'll always leave it down like this. And often, like if this was in grade 10 and 11, or grade 11 actually, you would factor these out and then see if you had a factor that crossed off. So for you guys, I've never seen it where they've made you factor it on the top. So ultimately, if you had to, you would want these factors so you could cancel off commons. So we never put the bottom together. I've never seen it. No. They could be like a... Alrighty. So this one I have 4 over 2y plus 5. And I'm going to multiply it by y minus 3. And multiply this one by y minus 3. I always like putting the common factor that you're missing at the beginning. It's just something I like doing that I'm always putting in the same spot. minus, then I'm going to leave a space, so y minus 3. I'm going to multiply this one by 2y plus 5. Then I write them over the common denominator. Y minus 3, 2y plus 5. And I can just write them back up. So y minus 3 times 4 minus 2y plus 5 times 1. And then I distribute the top, right? Keep the bottom. So I'm going to get y times 4, which is 4y, negative 3 times 4, which is negative 12, minus, and then I'm going to go bracket because I have more than one term behind the back, right? And I have to make sure I distribute it. So I get 2y times 1, 5 times 1. What happens when you multiply something by 1? Stays the same. So I'm going to have 2y plus 5 here. But the catch is that I have to remember to change the signs, subtract. So I'm going to get 4y minus 12 minus 2y minus 5 over y minus 3, 2y plus 5. And then I collect like terms. So I get 4y minus 2y is positive 2y. And then negative 12 minus 5 is negative 17 over y minus 3, 2y plus 5. And if I went to state non-permissible values, I'd say y can't equal 3. And when I solve this one out, what do I get? Negative 5 divided by 2. Your homework is just for the last, for probably about 10 minutes. You're going to get this time to work on it. You're going to look at questions 1 and 2 that follow after it. I want you to do A and C for both. So 1 AC, 2 AC. You have about 10 minutes. So example 2. What's different with example 2 than example 1? What's different than example 2 than example 1? This one has an x squared. These ones have numbers that we can maybe take out. The previous ones were like x plus 2 and x minus 5. I couldn't take a GCF out. I couldn't factor them or anything, right? I couldn't do anything to the bottoms. They just were different, and I multiplied by them. Okay? These ones, the left denominator, I could take out a 5, and I'd be left with what behind? The right one, I could take out a 2, and I'd be left with x plus 1. Then they both would have an x plus 1, so they'd be similar. Okay? Let's see what we do. So we're going to get 4 over 5 times x plus 1. So if you can take a GCF out of the denominator, or you can do a difference of squares, you're going to do that first to see if you can make common denominators. Then we're going to add 3 over 2 x plus 1. Now they're close. They both have an x plus 1, which is fantastic. So I don't have to multiply them by x plus 1 at all because they both have x plus 1s in their denominator. One is a 5, though, and the other one has a 2. What can I make them common? 10. So I'm going to multiply this one by 2 and 2. I'm going to multiply this one by 5 and 5. Then they'll have common denominators of 10 x plus 1, right? If you don't take the 5 and the 2 out, you're going to be multiplying this one by 2x plus 2. You're going to be multiplying this one by 5x plus 5, and you're going to get a way uglier thing that you're going to have to cancel off stuff and reduce, okay? So always check first before you make a common denominator. Can I take out a GCF, or are they difference of squares? So on the top, I'm left with 8 over 10 x plus 1. Plus, this one I'm left with 15 over 10 x plus 1. Now they have common denominators. So I can just write the entire numerators over one denominator, right? So I get 10x plus 1 in the bottom, and then 8 plus 15. Then what can I do? Just collect like terms. So what's 8 plus 15? 23 over 10 x plus 1. Can I take anything out of the 23 and the 10? Trick question? Nope. And then x can't equal -1 is what I put. So only for division do you state NPVs of not just the denominator. Addition, subtraction is just the denominator. Multiplication, just the denominator. Simplifying, just the denominator. It's only division where you state the denominators and the top right numerator, right? B, what could I do? What could I do with B? The bottom left, can I take anything out of it? No. The bottom right, can I take anything out of it? What? An x. If I take an x out, I'm left with x plus 2. So what do they both have in common now? An x. So do I have to multiply them by any more x's? No. The right-hand side, however, has an x plus 2. The left-hand side needs an x plus 2. So I'm going to multiply them both by x plus 2 on the left. So on the top left, I'm left with x plus 2 times 1. What's that? X plus 2. Then minus 1 all over the denominator, x plus 2. Because the moment I have a common denominator, I can write them all over it. What's my last step? Collect like terms. So I'm going to get x plus 2 minus 1 is plus 1 over x plus 2. Can I cross this x off with the x from x plus 1? Whenever it's x plus 1, what is it? Connected. It's one thing. So unless I have an x plus 1 on the bottom, it's not going anywhere. Do I have to state non-permissible values for this x plus 1? No, only for these bottom ones. So the x by itself will get me x can't equal 0, and x plus 2 gets me -2. So we're going to go to 3 and 4. Do AC for both of them. So that's your homework. 1 to 4, A and C. 1 to 4, A and C for all of them. Okay? And then you need to work on that hand in. 1 to 4, AC. Do this first while you're here so you can ask me questions if you're stuck. Same. Just keeps going. Like what they said.